Okay, student, kita kembali lagi dengan topik kedua seterusnya bagi chapter 3 iaitu elastic IP. Okay. Alright, so what is elastic IP? So mari kita tengok apa itu elastic IP. It's a public IP address that can be accessed directly over the internet. Okay, and an EIP consists of public IP address and some amount of public network egress bandwidth. EIP can be bound to or unbound from ECS, BMS, virtual IP addresses, NAT gateway and load balancer. So actually this slide is the same with the previous slide in the introduction, the introduction slide. So you must need to understand and remember lah, EIP can only bound to this 1, 2, 3, 4 and 5 services. Okay. So we drill down to the type of EIP. So basically, so comparison when we use to EIP. So this is BGP. Why is it EIP type? So okay, this is a comparison dimension of BGP. Okay, static BGP. Is this one if you want to bound to BGP, static BGP, dynamic static BGP, and preferred BGP. I think this one is wrong. Okay, the definition of static BGP is static route, manually configured, must be reconfigured anytime, the network topology. And for the dynamic, is dynamic provide automatic failover and choose the optimal paths based on the real-time network condition and based on policy. The preferred BGP is premium BGP, chooses the optimal path and ensure low latency and high quality network. So this one it use interconnect with line of multiple mainstream carrier. Okay. So the assurance is for the static BGP, when changes occur on a network that uses static BGP, the manual configuration takes some time and high availability cannot be guaranteed. This is for static. Okay, for dynamic, it might be able to quickly select or another optimal path to take over services. So you can see the service availability is 99.95% compared to static BGP, whereas the preferred BGP also have the capability of the dynamic. Okay, BGP. Okay, now we watch the application scenario binding EIP to ECS. Okay, so you can bind EIP to an ECS, EIP, elastic IP address, to an elastic cloud server, ECS, to enable the elastic cloud server to access the internet. So we have ECS, then we have bare metal server. So both of these, as the introduction of EIP, it can be bound to EIP to connect to the internet. So both of the ECS and BMS must be inside the VPC, Virtual Private Cloud. Okay, so let's say we want to bind EIP to a NAT gateway. Okay, so EIP can also bound to NAT gateway, and SNAT and DNAT are added. So what is SNAT? SNAT means a source NAT, network address generation, and DNAT refer to destination network address translation. Okay, multiple servers such as ECS, Elastic Cloud Server, and BMS, bare metal server, can use the same EIP to access the internet and provide services accessible from the internet. So this is the picture is a little bit small. So as you can see here, so we have VPC, AZ region 1, AZ available zone 2, and inside the AZ1 we have two subnet, subnet 1 and subnet 3, and inside the available zone 2 we have subnet 2 and subnet 4. Okay, where each in the subnet we already configure. Let's say we want to configure ACS, Elastic Cloud Server, and BMS, bare metal server, on all the subnet. So we can configure for subnet 1 to communicate with subnet 2 and subnet 3 to communicate with subnet 4, whereas subnet 1 and subnet 3 cannot communicate with each other, and subnet 2 and subnet 4 cannot communicate with each other. Okay, but all of these we can connect via the NAT gateway using the SNAT and DNAT rules. Then we can bind the NAT using the EIP to go to the internet. Okay, now the next one is, let's say you want to buy EIP to a load balancer. So after you attach EIP to a load balancer, the load balancer can distribute requests from the internet to the back-end server. So let's say we have this one VPC. Let's say we have 4 ECS, Elastic Cloud Server, which is connected to Elastic load balance. When we want to banner all the traffic in the ECS, we use the ELB. So to connect to the internet, instead of using each individual ECS, we can use the ELP to connect to the EIP. We using EIP to connect to internet. Okay. Alright. So this is for load EIP. So now I go to the third. Okay. Third part of the chapter 3, which is like elastic load balance, ELB. So what is ELB? So ELB is elastic load balance, which is automatically distribute incoming traffic across multiple backend server based on the listening rules that the personal configure. So ELB expand the service capability of your application and improve the availability by eliminating single point of failure. In short, we call it spoof. Okay, let's say we have a user which is connected to internet, and inside the cloud we have a database which is have a lot of server. Let's say have 3 server here. It might be the application server, the DNS web server, whatsoever server which is connected to database, and we can use the ELB in the middle between the internet and the cloud. Okay, so we can use this one. This is ELB to manage the incoming traffic to the multiple backend server and distribute it evenly. Okay, so that it can eliminating spoof. Alright. So now, what the advantage of elastic load balancer? Okay, the first one is robust performance. The second one is high availability. The third one is flexible scalability. The third one is flexible forwarding. The fourth one, the fifth one bundles load balancing, and the last one is easy to use. So what is the meaning of robust performance? So let's say a cluster support 100 million concurrent connection. 100 million concurrent connection. So meeting with user massive service access requirement. It can able to support all this much connection. Okay, ELB able to do this. Okay, high availability. Let's say the cluster based deployment intracity active. Okay, DR for multiple AZ availability zone and seamless real-time switch over. Let's say they have a disaster recovery, able to switch, okay, between AZ effectively, okay, and quickly. Okay, flexible scalability is able to automatic distribution based on application traffic, seamless integration with the AS service, and flexible expansion of external service capability of user application. Okay, and for the flexible forwarding is it support multiple application policies and forwarding policies and forward traffic in multiple mode to meet different forwarding requirement. Okay, bundle load balancing is exclusive. ELB provide the hybrid load balancing capability, which is it can cross VPC backend to uniformly load resource between on and off cloud. Okay, and last one is able the ability to deploy the ELB quickly and take effect in real time. Okay, so they have a multiple schedule algorithm available. Okay, it's very fast switch over. Okay, now this is the example of the simple ELB architecture. As you can see here, it consists of 3 components. So you must remember, ELB consists of 3 components. The first one is load balancer. The second one is listener, and the last one is backend server group. So this is a load balancer. All this under the load balancer, we have the listener. So the listener is based on the backend server that has been configured. Okay, let's say in the backend server we have 2 backend server here. Okay, this 2 backend server, and this one we have on this part we have 5 backend server, this part we only have 2 backend server. Okay, let's say this one the configure for port, okay, for 43. This one for 81, and this one this 3 backend server for port 80, and these 2 server for port 81. Okay, so the listener able under the load balancer listen to the particular port, which is this one is the port and server is 2 ECS. So you will listen to this 2 ECS for the port for 3, and this port 88, okay, for all this 1 2 3. So this one might be running both port 88 and 80. Okay, so it can balance all this based on the 3 component that one. Okay, so the load balancer distribute incoming traffic across multiple backend server and can work on both public and private network. So let's say you configure is the public network and private network in your VPC. Okay, then you can do the load. You can configure ELB. So let's say in this one, okay, you have one VPC. Okay, then you have 4 server. Okay, ECL. Let's say ECS server, 4 ECS server. And you can balance, then you configure this one as a public, okay, as a public network. Then you can balance all this server using only ELB, which is the ELB we connected to gateway using EIP through the internet. And it's the same with the private network. So it's the same. Let's say the private network you have ECS here 4. But then you have another 2 segment of ECS for different server part. Okay, these 2 server and these 2 server, and you can connect all of these into one ELB for the balancing. Okay, so this internet didn't need to use the internet. It's inside. Okay, inside the third organization part lah. Okay, next. So what is ELB listener? It's listen on request from client and route the request to backend server based on the setting that you configure when you add the listener. So let's say you have listening protocol. Okay, at layer 4 we have TCP or UDP, and layer 7 let's say we have HTTP or HTTPS. So we have the listener have the load balancing algorithm using might be a route robin, weighted-less connection, source IP hash, and connection ID, which is connection ID supported only by dedicated load balance. So it will load balance based on the listening protocol and the algorithm. Okay, when you add to the listener, which you need to configure the port to be inside the listener lah. Okay, so you can request backend server based on setting. So you need to setting this listener. Okay, so backend server group. So in the backend server group, it's a group of cloud server that have same features. So when you add a listener, so if you don't add the listener, it's not able to listen to the server. If you are not able to listen, the load balance cannot be works. So you need to add the listener. And then you select a load balancing algorithm. Okay, this is all the algorithm that they support. Okay, and create or select a backend server group. So incoming traffic is routed to the corresponding backend server group based on the listener configuration. So you need to configure the listener if you want to use the elastic load balance to balance all the traffic between your backend server. Okay, based on the service that you up lah. Okay, so what is this ELB health check? Okay, ELB health check means is periodically send heartbeat message to associated backend server to check their health and ensure that traffic is distributed only to healthy server. Okay, this can improve the availability of your application. So let's say if backend server is unhealthy, the load balancer stop routing traffic to it. Okay, so the load balancer will resume routing request to the backend server after it recover. What's the meaning backend server is unhealthy? That means that let's say the data is a lot of discarded or is too congested, so it will stop the traffic for the moment, and so it will forward the traffic to the other server which are not congested. So when the problem backend server is resumed as usual, that we will have the load balancer will be back to give the the packet back to the backend server. Okay, so they need to have the health check lah. Okay, this is how they balance the data between all the server, to transit between all the server lah. Okay, what is ELB load balancing algorithm? So they have 4. Okay, the first one is weighted round robin, the second one is weighted list, source IP or connection ID. So they have 4 type of algorithm. So for using round robin, so as you know, this is like 50-50. Okay, between each of the server. So you have the 4 server, it will distribute among the 4 server using the average of all that. Okay, so weighted list is based on the weight of the connection. Okay, the least one connection that we go through that one. Okay, the request we go to that one. Okay, the source IP hash based on the IP lah. So the connection ID is based on the connection request of the client. You go to that server. Okay, so how to configure ELP? So the process is you need to create a load balancer by clicking a by elastic load balancer, then select the load balancer type and configure the network. So then you add a listener. Okay, locate the created load balancer. Okay, that is one that you create. Then configure a protocol endpoint, and then you add a backup server group. Select a load balancing algorithm. So you need to choose what algorithm that you want to use. Then you can configure a health check. Okay, so you then is good to go. Okay, so this is how you do it. The example in the CCAR Alpha-ish. Okay, dashboard. So before you create a load balancer, you need to plan it region, network, and protocol and backend server. So you need to have this plan first before you create the load balancer. So then after you create load balancer, then add a listener. So you need to create at least one listener. A listener listen on request from client and route the request to backend server based on the setting that you configure when you add the listener. Okay, so let's say this one you name it as listener VV. Use the port HTTP with the port 8881. So the value is between 1 to 65535. Depend to the organization what they want to use. Okay, so ELB configuration. Then after you configure, you create load balancer. After you add a listener, then you need to add a backend server group. So which group that you want to add to the listener? So the group, the backend server group is collection of cloud server that have the same features and will receive the request routed by the load balancer. So you click this one, then you can choose which ECS that you want to add to the listener. Okay, alright, so example the application scenario. Let's say we have heavy traffic application. Okay, for an application with heavy traffic such as large web portal or mobile app store, okay, elastic load balancer able to evenly distribute incoming traffic to multiple backend servers by balancing the load while ensuring stable performance. So sticky session ensure that requests from one client are always forwarded to the same backend server. So let's say we have down here we have 2 backend server A and B. Okay, it configure both server to one ELB to load balancer between them, so they have an internet. So let's say you use this algorithm, source IP hash. Okay, algorithm. So if let's say it request for A or request for B, so it will go lah based on the performance, based on the request of the client. Okay, let's say that we have application with different traffic. Okay, for application that have predictable peak and through in traffic volume, ELB, elastic load balancer, works with AS. So AS means auto scaling to add or remove backend server to keep up with changing demands. One example is like flash sale, during which let's say Lazada make a or Shopee make a flash sale, okay, which they are predictable traffic spike that only last a short while. So ELB can work with AS auto scaling to run only the required number of backend server needed to handle the load of your application. So let's say you have backend server, 4 backend server, okay, so you have configured all the 4 to ELB. We have a sticky we have elastic IP go through the internet. So let's say we have a flash share, so it able to work with AS, okay, auto scaling, so based to add or remove backend server based on the incoming traffic, okay. Alright, let's say the scenario to have 0 spoof, okay, so ELB able to perform health check on backend server. If any backend server is unhealthy, so ELB will not route request to this server until it required. So spoof last time tadi dah ni dah baca, okay, of failure, kita tak nak ada failure lah. Okay, this make ELB could choose for running application. So let's say this have tak sihat lah, dia sakit sekejap, okay, so dia takkan hantar ke sini lah. We go to all these 2 backend server. So this one will stop temporary until it recover, then the traffic will go back to this one, okay. So that's all for chapter 3. Okay, so we have cover for 3 part, which is we go back to this one. We already cover VPC, okay, in this chapter, elastic IP dan elastic load balance. So another virtual private network and net gateway I will cover in the next video. Okay, we will meet again later on.